As our next topic, I would like to look at evaluating inverse trig functions. The main thing that we have to keep in mind is we have to keep in mind what we learned about restrictions on the original function that will make the inverse an actual function. So let's look at a couple of examples. Find sine inverse of negative square root of 3 over 2. The first thing that we need to realize is when they ask you find the inverse trig function, they're actually asking you to find an angle. So in other words, an inverse trig function is equal to an angle. The thing that's given on the inside here is the value. And so this being the case, negative square root of 3 over 2 is the actual value of sine. Sine, we know, is y over r. And so the first thing you want to do is you want to go to an xy axis and you want to draw the possible triangles that would result from y being negative square root of 3 and r being 2. Now, there are two quadrants in which y can be negative. Y can be negative either in quadrant 3 or in quadrant 4. Alright, let's go ahead and label these two triangles. We have the y value being negative square root of 3, negative square root of 3, the r value being 2. Now, depending on which quadrant you're in, depends on the sign of your x. So, in quadrant 4, the sign of x would be positive. In quadrant 3, it would be negative. Alright, now, the problem from this point is determining the actual answer for theta to compute this inverse. Recall the restriction on theta for the inverse of sine. The restriction for sine was that theta had to be in between negative pi over 2 and pi over 2. And it could include either one of those. Well, on our axes over here, here's pi over 2, here's negative pi over 2, making sure to take into consideration you swing that direction. Okay, this being the case, we couldn't possibly have that triangle over in the third quadrant. Instead, the only triangle we're interested in is the triangle in the fourth quadrant. What is our reference angle? Our reference angle there is a 60-degree angle, we know. Okay, but because we have a restriction on sine inverse, and to obtain an angle there in the fourth quadrant, we obtain it by rotating clockwise and get a negative angle, then this particular value would end up being negative 60 degrees or negative pi over 3. So that would be the answer for sine inverse of negative 3/2. Let's think of another example. Consider finding the inverse cosine of the negative square root of 2 over 2. Okay, once again, we need to remember that when we find an inverse cosine, we're actually finding the value of an angle. Okay, and later on we'll discover what that angle is. Also remember that whatever they give you on the inside is the value of cosine. And so we know cosine is x over r. Now the problem with this particular example is that you can see that negative square root of 2 over 2 has been rationalized. If we unrationalize it, that is actually negative 1 over the square root of 2. So we can see that the x is negative 1 and the r is the square root of 2. Let's draw that. Okay, x is negative in two quadrants. It can either be negative right in here, or it can be negative in there. If we label these triangles, we have the x is -1, the r is the square root of 2, and then this we know is actually a 45-degree reference angle, so our other sides would be +1 in the second quadrant, -1 in the third quadrant. Now we need to consider the restrictions on my angle for the inverse of cosine. So recall that for cosine inverse, theta is restricted to be anything between 0 and pi, including either 0 or pi. So that means that this angle down, or that triangle down there, is not going to be considered. The reference angle for the one in the second quadrant we know is 45 degrees. The only thing you have to be careful about is you have to be careful that because we're looking in between 0 and pi, we actually need to determine what this angle is. Okay, theta, the angle that we're looking for, would actually be 180 degrees minus 45 degrees. Okay, and that's equal to 135, or 3 pi over 4. Alright, so the answer to this particular question is either 135 degrees, or in radians you could say 3 pi over 4. Okay, let's consider another example. Let's say that we need to find the inverse tangent of -1. We realize that we're looking for an angle measure. Okay. We also realize that the -1 is the value of tangent. -1 could be either written as -1 over 1 or 1 over -1. We know this is the value of tangent, which is y over x. Let's draw a picture of where those could possibly be. Alright, if y was -1 and x was +1, we would have to be in quadrant 4. Y is -1, x is +1. That would leave the other side to be square root of 2 because we recognize this as a special triangle. Okay, the other situation, y could be +1 and x could be -1. That would happen in quadrant 2. You have your y value being positive, your x value being -1, and then this side would be square root of 2. Okay, both of these having reference angles of 45 degrees. Now we need to think about the restrictions for inverse tangent. So for inverse tangent, the restriction on theta was that theta had to be in between -pi over 2 to pi over 2, and we couldn't include either one of those. That being the case, here is pi over 2, here is -pi over 2 when you're swinging in that direction, so it couldn't be the triangle in quadrant 2. Now, making sure we understand that this reference angle is 45, but based on the restriction for tangent, we have to rotate in the negative direction to achieve that angle, then the answer would end up being theta equals -45 degrees, or pi over 4. And so that would be the value that I would put in up above. This concludes my lesson on evaluating inverse trig functions.